So I'm really happy to be here. My name is Becky. I live in California. I've been blacksmithing for about 10 years and teaching for about half of that time locally and also demonstrating. With the pandemic, I started teaching on Zoom for the California Blacksmith Association, and this presentation was created for their this is a slightly shortened version of that presentation, but it was created for their content that's mostly aimed at intermediate level blacksmith students. So tonight I'll be talking about upset square corners. And I'll just give a shout out to Mark Asbury, who is here, who provided some of the photographs and also the video for this. So we're really happy to see him here, and he'll keep me honest. Let's talk about what makes a good square corner. So first of all, we want it to be sharp and square on the outside. We'd like it to have a small radius on the inside, and you can see in this photo here, there's a really small radius, and this is a function of forging that corner a little bit open of 90 degrees when we're doing the forging, and that is to prevent cracking in that corner. And I'll go into some detail about how to prevent that cracking. We'd like our corner to be in the desired location. In other words, where we intend it to be. We'd like our corner to maintain parent stock dimension in the corner and the legs with no thinning. We'd like our legs to be straight with no undesired twists or bending. We'd like the corner itself to be free of cracks or cold shuts, and both the corner and the legs to be free of galling and tool marks. Lastly, we'd like our corner to be exactly 90 degrees or whatever dimension is required for our project. Okay, so how do we achieve this? Okay, so let's start out with materials and tools. So stock. For the purpose of making a square corner, you can use any shape stock. So round stock works, square stock works, and flat works. If you're just starting out with square corners, I recommend using square stock because it's easiest to see what you're doing. You need a ruler or measuring device, a soapstone or silver pencil so you can mark the location of your corner, a center punch, again, to mark the location of the corner, a vise. We'll be working at a combination of the vise and the anvil, and this will allow us to make a very precise corner. We need tongs that are the right dimension to hold the stock that we're working with, a scrolling wrench, and a light hammer. A light hammer is required here because for upsetting, we want to use light, rapid blows to get the upset into that corner. Lastly, a framing square can be useful to determine if your corner is actually square. Okay, some considerations about working at the vise. We'd like our vise to have rounded edges, the jaws clean and free of burrs, and the jaws to close evenly. And this is really so that we're not marking our corner as we work. So you can see in this upper photo here, this jaw has rounded corners. It's nice and clean on the inside and the jaws close evenly. So this vise would be good for this process. This lower vise here, you can see that there's some sharp edges, the jaws don't close evenly. So this may cause marking on the inside of our corner or on the legs. So if you don't have a workable vise, consider using jaw covers or do the entire process at your anvil. So our first step is to set up the bend. We want to center punch the location of the corner, as you see in this photo. Our next step is we need to choose an appropriately sized scrolling wrench for our stock. These are the scrolling wrenches. These were made by Victoria Ritter. These work really well for this process. But if you're like me, you might have a whole bunch of scrolling wrenches in your shop. And some of them are better than others for bending square corners. So if you look at this one on the left, and I'll try not to give any numbers here because I'm not good at the metric system, but this one is too small for most sizes of stock. This one here will work pretty well. What about this one? This one has a big end here that will get in the way of the vise when you do the bend. So this one won't give you a tight enough bend. This last one also will not work very well because it's spaced too far apart. You'll have a bend that's too loose, and you'll have to do more work to get the corner made. Okay, once you've picked your scrolling wrench, you want to measure the height of the scrolling wrench when it's in position on your bar. So if you position it in the bar as if you were about to do the bend, then measure the distance from the bar to the top of the scrolling wrench. Then you can use that height to determine where to position the bar and the wrench in your vise. And this will give you a very precise bend every time. So let's look at a picture of that. So here we can see we've taken that measurement and we've positioned the center punch mark that distance away from the vise. And again, the scrolling wrench that distance away from the center punch mark. That way, when you do the bend, it will be in the right location. Next, mark your vise. Okay, so here we've put everything in position and then we've marked the vise. Now, why are we doing this? When we take the bar out of the fire, we won't be able to see that center punch mark easily. So this will allow us to position the bar quickly without losing heat. So we have a photo of that here. So you can see that when the bar is hot, you can get it into position very quickly and do that bend. Okay, so now the initial bend. Something that happens when you use your scrolling wrench to bend the bar is that we have a tendency to push down with our hand, and that will bend the bar downwards and or twist it. To avoid doing this, consider putting your scrolling wrench on the underside of the bar so that you can't push down. You actually can't push down when you're doing that, and you can see better if you're twisting it. So this is to avoid twisting or pushing the bar down during the bend. So use that scrolling wrench from below. The second pointer is to bend away from you. Why are we doing this? We have heat in the bar, so we can immediately start forging right after we bend that bar. And when we are doing that upset into the corner, we want that corner towards us so that the arc of our hammer blow is pulling and upsetting that material into the corner where we want it. Okay, this is a really important point. Bend to approximately 100 to 110 degrees. Don't go all the way to a 90-degree bend at this point. And this gets back to that first slide where I was talking about the small radius in the corner. So when you bend a bar, the dimension on the inside shortens. The dimension on the outside lengthens. So what happens as you're forging that corner is that the inside corner becomes square before you get enough material into that outside corner. So if you're forging it at exactly 90 degrees, that inside corner, the material will start to fold over onto itself and set you up for a crack later on. So to avoid that, keep your bar at 100 degrees. So I have a photo here. You can see I have my square and my bend is open of that. And then maintain that 100-degree bend as during the entire process of forging the corner. Okay, you can also bend over a well-rounded edge of your anvil. Okay, so let's watch a video of this. And this is Mark. You can see he's setting up. He has the line already on his vise so he can get that into position quickly. He knows exactly where to put his scrolling wrench. Notice the very well-rounded edges of the scrolling wrench, and he's stopping at about 100 degrees. There's enough heat in this bar at this point for him to start forging. So notice here that he pulls the bar out a little bit so that the jaws won't dig into or mark the corner when he starts forging. Now I'll talk this through in the next slide. But what he's doing here is finding the flat of the bar and aligning his hammer angle in alignment with that and extending that flat towards his center punch mark, which you see right here. You'll notice that the parent stock thickness thickens here. So he'll need to bring this over to the anvil to bring that back to parent stock thickness. And you'll notice also that he never goes below the center punch mark. He's extending the flat from where it's flat, and this can be quite far up the bar, towards himself, towards that center punch mark. Okay, so let's talk through that just in a slide. So forging square corners in the vise. So again, the reason to use the vise is that it's very precise. You have that other leg captured in the vise. So to set it up, we want to position the bar so the bend is away from you. Second, we want to ensure that the corner is sufficient distance from the vise to prevent galling or marking in that corner. And again, we saw Mark do that in the video, is to pull it out just a little bit so that the jaws of the vise don't dig into the corner. This we couldn't see in the video. You want to grasp the leg of the bar, the free leg, with a pair of tongs, with your tong hand, to prevent that corner from closing. When you're forging that corner, there's a tendency of that corner to close up. So by holding onto it with a pair of tongs in your other hand, you can maintain that 100-degree bend during the entire process. Okay, next, use light, rapid blows with a light hammer. And you'll notice here, this is a light hammer. And the reason for that is we're trying to upset material right here in this corner. We want to use light, rapid blows to do that. Okay, the process, find the flat. This can be quite far up the bar, depending on what scrolling wrench we use to do the bend. Find where it's flat, angle your hammer in alignment with that flat, and keep that hammer alignment the entire time. Never follow the corner around. What we're trying to do is flatten this bend into that corner, and at the same time upset material into the corner. Okay, start to straighten the curve, but don't go below the center punch mark. And I think I have a picture of that here. So here you can see what we're doing is we're flattening that bend up to the center punch mark. And keep in mind that we're doing two things. We're flattening, but we're also upsetting. And it will take successive forgings to get sufficient material into this corner. And as we flatten, we are upsetting this material. You can see that you're upsetting it into the corner. Once we've gotten to this stage, we flip the bar to work on the other side. And I have a photo of this here. We don't have that center punch mark there. So we're using the flat on the other side as a guide of how far to forge that flat. Okay, so let's watch a video of this. This is a continuation of the previous
Then closing.
And he's flipped the bar over and now he's working on the other side. You can see that he's found the flat of the bar. He's keeping his hammer angle in alignment. He's using light, rapid blows and extending that flat to the corner. He stops when he gets to using the flat of the other side as a guide. Then you flip the bar over and do this again. And creating a square corner is a process of doing this over and over until you've upset sufficient material into that corner. And so here he's flipped it over. He's found the flat of the bar. And he's continuing until he gets to that center punch mark. Okay, so this is the process of repeating until you get the desired results. Some points. Keep the center line of your hammer above the inside edge of the other leg of the bar. We don't want the hammer to extend past that point. We also don't want our hammer to follow the curve around. Upsetting will thicken the stock in the corner, so flatten this at the anvil as you work. Always maintain that 100-degree angle. Okay, so we're watching a video of this. Again, this is that same corner. You can see Mark is finding the flat. He's extending it towards the corner using light, rapid blows. He is holding the bar open with his other hand with a pair of tongs. And you can see now that he's getting pretty close. And again, finding the flat, and progressively that flat moves closer and closer to the corner. And you can start to see the corner take shape there. Again, you can notice the thickening in the stock, and he'll go over to the anvil and flatten that in between heats. And you can see here, this is pretty close, and this other side needs a bit more work. At this point, you're ready to move to the anvil so that you can move back and forth between the two sides. So working at the anvil has some considerations. So first of all, we want to make sure that the heat is concentrated just in the corner area. And in order to do this, we'll need to do some strategic quenching. The reason why is that we know that the force of the hammer blow goes to wherever we have heat in the bar. So if we have heat in the leg, it will bend instead of forging that corner. So to do this, we want to take a yellow heat. This will give you that time to quench the legs. Isolate that heat to the corner with strategic quenching. There's two basic blows working at the anvil. The vertical blow, which you see in this picture here, which is forging from above. This is a quite strong blow because you have the mass of the anvil beneath it. Keep in mind that the same hammer angle applies at the anvil as well. You want to make sure that your hammer is angled in alignment with the bar. This is a little bit more difficult to see at the anvil, so you do need to pay attention to that. The next kind of blow is the horizontal blow, which is hitting back towards your body. Note that this is not up against the edge of the anvil. Just go back here. The vertical blow is stronger than the horizontal blow, so you'll need to compensate accordingly. So for maybe every 2-3 vertical blows, you need to do 5-6 horizontal blows to get the same level of upsetting. Okay, and so here's a photo of flattening the corner as you work to bring it back to that parent stock dimension. As you're upsetting, there will be growth in that parent stock thickness. Avoid forging on the corner of the anvil. That will thin your legs or your corner. And if your legs do bend or twist, correct before proceeding further, because if you do have a twist in there, you will forge that right into the corner, and then it's difficult to take it out. And then your last step is to bring it to 90 degrees when your corner is nearly complete, and then just go back and clean up that corner. Okay, so let's watch a video of this. And this is Mark working at the anvil. This is the horizontal blow. He's keeping that hammer in alignment with the angle of the bar. This is the vertical blow. And notice that he's doing more horizontal blows than he is vertical blows. And the benefit at this point of working at the anvil is that you can very precisely go back and forth between the two sides. And there he's flattening the thickness back to parent stock. And he's very close to his corner now. So this is very light blows, cleaning up that corner. Okay, so what can go wrong? The first problem that is common with working with corners is overbending, which leads to cracks. So forging at 90 degrees will cause cracking, again, because that inside material is shorter than that outside material. So before you get your corner formed on the outside, your inside will start to fold over itself. Similarly, if you're forging and your corner starts to close up, if you're not holding it with tongs and you try to reopen it, that will cause cracking. So to prevent this, be sure to keep that initial bend to 100 to 110 degrees and maintain that degree of bend as you work. Here's a problem. If your hammer is not aligned with the bar, it can cause bending, unanticipated bending in that corner, which can lead to cracks. So keep that hammer in alignment with the flat of the bar. And again, use tongs in your tong hand to prevent the corner from closing. And go to 90 degrees when your corner is nearly complete. Okay, here's another problem, over forging. So here in this photo, we see that the flat of the leg is extended too far. So how do we prevent this? Don't forge past the center punch mark. You can see in this case that the corner is actually moved at this point. It's here, it's not where our center punch is. And there's not a lot that we can do to get that back. Use light hammer blows with light, rapid blows. Sneak up on your corner and work evenly. Okay, so thinning. Here we see a photo of a corner that's been thinned. There's two problems going on in this picture. One is that the angle of the hammer is not in alignment with the flat. And the other problem is that the hammer is below that center line. So to prevent thinning, keep your hammer aligned with the angle of the leg. Don't allow the center line of the hammer to go past the center of the opposite leg. Avoid hammering past your center punch mark, and absolutely don't hammer against the edge of your anvil. Okay, galling or other undesired tool marks. The easiest way to fix this is to make sure all your tools have rounded edges. Your scrolling wrench is round and your vise has rounded edges. Also, position your bar sufficiently far away from the jaws of your vise so that you don't, the jaws aren't hitting into your corner. If you are having problems with that in your vise, you can quench the leg that's in the vise so it's hard and it can't mark or gall as easily. And again, avoid the temptation to square the corner against the edge of the anvil because that's another source of marking. Okay, so twists or bends. So again, the first place that we may inadvertently put in a twist or bend is in that that first bend. So if you've done that, correct it before proceeding further. We don't want to forge that twist or that twist really into that corner. So remove that in the vise with a twisting wrench. To prevent it, use a scrolling wrench positioned from below to prevent that tendency to push down or twist as we do the bend. If you're working at an anvil, be sure to isolate your heat to the corner with strategic quenching to prevent bending the legs as you're forging. And again, at the anvil, if you're getting twists at the anvil, it's usually a problem with the alignment of your hammer blows. So try to look at what you're doing with your hammer to prevent that from happening in the first place.
The first question comes from Mariano. How you can calculate where it has to be located, the corner. For example, if I want to make a piece and locate the corner in a specific point, for example, 100 times 150 millimeter in each leg, or something like this. Wie kann man berechnen, an welcher Stelle die Ecke sein soll am Ende? Zum Beispiel, wenn ich ein Stück mache und die Ecke so ist, dass das eine Bein 100 und das andere 150 Millimeter lang sind oder so etwas in der Art.
That's a great question. I didn't put it into the presentation because it takes too long. But so here we have a corner. So when you make a corner, this inside part gets shorter and the outside part gets longer. So if you're measuring, say from, you know, this end right here to here, that's not where you need to place the location of your corner. You need to place it, I wish I had a pointer. Let's see, I have a pencil. You need to place your corner right there, right? That's where you're placing, that's where you're measuring. So what you're measuring is the center line of the bar because that doesn't change when you put your corner. So if you, for example, have a frame that you're trying to make and you have a set dimension from here to there, what you need to measure is the center line of your bar. If you place your corner there, your corner will be in the wrong spot.
Also es ist folgendermaßen, man muss dabei die neutrale Phase berechnen, also an der neutralen Phase in der Mitte des Werkstücks entlang gehen, weil sich die äußere Seite streckt und die innere Seite, die wird gestaucht. Und wenn man dann an der äußeren Seite das Maß ansetzt, dann verrutscht die Ecke von der Stelle, wo sie hinterher sein soll. Und deswegen muss man in der Mitte des Werkstücks messen. Oder zur Mitte des Werkstücks messen und anzeichnen. So you put the center line plus the half of the piece, thanks. Also nimmt man die Mittellinie plus plus die Mitte des Stückes. Well, I have a question for the meantime, which is if it's a 90-degree bend, you said you should start with a 100-degree corner. Does this also apply if you have like a bigger degree angle? Do you always add like 10 degrees or how does that work? Well, falls man nicht eine rechtwinklige Ecke, sondern sagen wir mal eine größere, zum Beispiel eine 120 Grad winklige Ecke haben möchte, setzt man dann auch 10 Grad mehr, also 130 Grad an, oder wie geht man da vor?
Okay, so no, it's only that 90 degrees. And I don't know if you guys can see this. Just for the purpose of this presentation, I made a sample bar where I forged it right at 90 degrees. I don't know if you can see it, but there's that crack. It's the material is folding over in on itself. And that's because this angle, the material in here is becoming square before the outside is square. So you get a really clear fold right there. If the angle is more open than that, it can't happen. So if you're trying to forge, for example, a 120 degree angle corner, no, it won't square up on the inside first. It only happens at 90 degrees or smaller.
Okay. Ja, genau. Also für größere Winkel ist das kein Problem. Das passiert nur bei 90 Grad und kleineren Ecken. Genau. Dieses Überlappen und dass da ein Riss entsteht. So the next question is from Steve Rue about, and the question is keeping round bar round, dass man rundes Material rund hält.
In forging, you said you're forging a square bar, a round bar to a square corner. What do you use the same how do you round it up? Do you then put it into swages, etc., and then you would have to make allowances for the movement of the corner in keeping it accurate? Is that how you proceed with that? In forging a square corner on a round bar?
Also, die Frage ist diese, genau, wenn man rundes Ausgangsmaterial hat und man möchte da drin eine rechtwinklige Ecke haben, wie geht man vor, dass die Ecke am Ende auch rechtwinklig ist und das Material aber trotzdem rund? Benutzt man ein Gesenk oder wie geht man dabei vor? And the answer.
So I'll have to be honest, I have not forged a square on a round where it maintains the round. I have seen that done. What I have done is, so for example, like making a hold fast, to give it some extra strength, you can use round bar and put a square corner right there. And that gives that extra strength on that hold fast. What you're talking about is rounding this part. And I've seen it. I haven't personally done it.
Okay. Yeah, I was just curious to see. I mean, I assume you would sway with a rounded swage on the corner and then hammer the swage.
Die Antwort ist, Becky hat das bisher selber nicht gemacht, um ehrlich zu sein. Allerdings hat sie gesehen, dass das schon passiert ist. Was sie wohl gemacht hat, ist zum Beispiel bei Holdfast, das hat sie ja dann auch in die Kamera gehalten. Auf Deutsch ist das sowas wie Schwanenhals oder Boxfuß, je nachdem. Genau, da hat sie unten rundes Material und das wird aber oben eckig ausgeschmiedet, damit die Ecke stärker wird. Das hat sie wohl schon gemacht und Steve hat dazu als Kommentar gesagt, ja gut, dann nimmt man wohl wahrscheinlich ein entsprechendes Gesenk. Er hat das auch noch nicht gemacht, aber er fand das interessant zu fragen, wie das denn wohl gemacht würde. The next question is from Philip Verkammen. Do you work the same way with big sizes? For example, 30 millimeters, so this is about 1¼ inch or more. Yeah, something like that. Genau. Arbeitest du auf die gleiche Weise mit größeren Querschnitten, zum Beispiel 30 Millimeter aufwärts?
I have not done something that large. Once you get past an inch, for me, that's difficult to forge by hand. So I would say that, there may be some other way to do that. But as long as you can forge it by hand, if it's a size you can forge by hand, you can do it with this process.
Becky hat dazu geantwortet, dass sie das bisher an der Stelle so nicht gemacht hat. Sie hat nur bis zu etwa 25 Millimeter das gemacht, weil es darüber für sie schwierig wird, das von Hand zu machen, von Hand zu schmieden, über einen größeren Querschnitt von Hand zu schmieden. Und wahrscheinlich, sie vermutet, es gibt da andere Methoden, wenn man größere Querschnitte hat, weil man dann wahrscheinlich auch mit einem Zuschläger arbeiten muss. So I think that one has to also work with a striker or similar, or a power hammer or fly press. There is from Torbjörn Åman, which is a Swedish blacksmith, which is quite famous in YouTube. There is a tool which he makes to forge square corners. He uses a power hammer. One can the same tool also adapt to a fly press.
Yeah, that would make sense.
Probably something like this also works with a striker. And he makes a hold first, I think, from some thicker material than 25 millimeter. So that might be the way to go. In German, es gibt von Torbjörn Åman, das ist ein schwedischer Schmied, davon gibt es viele YouTube-Videos, gibt es ein Werkzeug, mit dem er runde Ecken macht, rechtwinklige Ecken macht. Und das spannt er benutzt das mit seinem Maschinenhammer. Man kann das aber auch für die Spindelpresse adaptieren und damit kann man wahrscheinlich auch größere Querschnitte bearbeiten.
I've sent a PDF of a book.
Oh, okay.
And there is a piece in it that's very interesting about corners, even square corners, bended
Diagonal.
Yes, like that. This explains it how they do it. It's very difficult. We did it one time in the school, and it's a lot of work. So I think it's an interesting. It's a digital book. It doesn't exist anymore, but it's interesting. Maybe everyone can use it. I think everybody receives it. The book.
Yeah. Well, you can click in the chat on download, and it's like 32 megabyte data, and then it downloads. So in German. Philipp hat gerade eine PDF-Datei in den Chat gepostet. Wenn man da draufklickt, dann wird die automatisch runtergeladen und abgespeichert. Philipp sagte, das Buch gibt es so nicht mehr, die ist also frei verfügbar. Und da wird auch beschrieben, wie man spitzere Winkel macht, diagonal schmiedet, was ziemlich kompliziert ist. Er hat das wohl einmal in der Schule gemacht, aber es ist sehr, sehr kompliziert. There has come a new question from Mariano. When you have done the square corner, then you can work in the edge of the anvil, or do you have some risk to damage the piece or make some crack? Wenn die Ecke, wenn du die rechtwinklige Ecke ausgeschmiedet hast, kann man dann auf der Ecke auf der Ambusskante arbeiten, oder gibt es dann immer noch das Risiko, dass man das Werkstück beschädigt oder einen Riss bekommt?
It's about, because, for example, if you want to make the round piece, like Steve make the question, maybe if you can put in the edge of the anvil, you can hammer a little to round the piece, but I'm not sure if you have some risk to make some crack there, because you are trying to push in the edge of the anvil. So you try to open in some ways the piece again. So maybe you have some risk, but.
So I would try to avoid using the side of the anvil to either close or open. So one thing you can do is if you put like a hardy block in your anvil, and I probably can't do this here, but so you have the hardy block here and you're hammering there. You can close, and if you want it to open, you don't have a block and you hammer and it will open. So that way you're not hammering in the corner, but you have something to force it up against. You could also, if you have the type of anvil that has the edge, like the one in the video, you can put it up against that and hammer again here to get it to close to that 90 degrees. you know, of course, you can carefully use the side of the anvil, but the risk is that you're thinning that corner if you're forging there.
Becky rät davon ab, die Seite des Ambosses zu nehmen, um die Ecke zu öffnen oder zu schließen. Was man wohl machen kann, ist zum Beispiel einen Ambossblock einsetzen in das Vierkantloch und dann dagegen, also gegen die Ecke schlagen, dann wird sie geöffnet, oder ohne einen Ambossblock und dann wird sie geschlossen. Paul Frost says, very interesting presentation. Thank you for doing this. Eine sehr interessante Präsentation. Vielen Dank dafür. Someone mentioned, Steve Rook, someone mentioned the fly press tool for corners. Yes, Steve, that was me. There's a YouTube video. I make a note that I put link to the YouTube video together with the news of the recording.
Oh, excellent, excellent. Interested to see that.
Ja, yes. Steve hat gefragt, da wurde ein Spindelpressenwerkzeug erwähnt für diese Sorte von Ecken. Und ich habe gesagt, ja genau, das war ich. Ich verlinke das Video mit der Nachricht über die Aufzeichnung. Ich mache mir jetzt mal eben eine Notiz. So I just do the note. So there is another question from Mariano, and he says, how close do you think it is possible to make two corners like that in one piece? For example, if you work 12 mm square bar or a half-inch bar. Genau. Die Frage ist, wie nah denkst du, kann man die zwei solche Ecken aneinander positionieren? Zum Beispiel, wenn man mit einem halben Inch oder Material oder einem 12 mm Material arbeitet. And the answer is?
Okay, so that's a great question. So it's easy to make that first square corner. The second one, and this is just using the vise and the anvil method. So the second one, let's say you put a corner here and you bend it, you can put this leg in the vise and hammer here, but you can't get that in the vise. So you have to do it at the anvil. So the closest you can get using this is how you can get your hammer in there. So if you put a bend right there, you know, you can get it, you know, wherever your hammer is. The other leg is easy because that's in the vise, right? This has to be done at the anvil. And there are some techniques to that. And again, it's about bracing it against something on the anvil, like a hardy block, or that edge of the anvil, so that your bend, it has a tendency to open up or close up as you're doing that second corner. So that second corner is much more difficult, and you're doing it at the vise. But how close? It's, I think, a function of your ability to forge with your hammer.
Okay, so the translation. Auf Deutsch, ja, ganz kurz gesagt, ist das davon abhängig, wie gut du mit dem Handhammer umgehen kannst oder mit dem Hammer grundsätzlich umgehen kannst. Je nachdem, wenn die Ecke, also du kannst das zum Beispiel in den Schraubstock einspannen und wenn du dann noch mit dem Hammer da dran kommst, dann ist das alles gut. Sie hat dann zum Beispiel gezeigt, wenn das relativ nah an der anderen Ecke ist, ist das sehr wahrscheinlich schwierig, mit dem Hammer da reinzukommen. Und deshalb muss man sowas dann am Amboss machen. Es kann dabei unterstützend sein, einen Ambossblock, so ein Gesenk für das Vierkantloch zu nehmen, was entsprechende Ecken hat. Das kann sein, dass die zweite Ecke dabei aufgeht oder sich schließt. Die muss man dann eventuell entsprechend abkühlen. Genau. Es wird auf jeden Fall erheblich schwieriger, wenn die nächste Ecke da reinkommt.
That first photo shows a double square corner, and those, I believe, are 2 1/4 inches apart. You have to do that second corner at the anvil. You can get the long leg of the bar into the vise, but you can't put the shorter part in there. So that side you have to forge at the anvil.
Genau. Becky hat noch mal kurz die erste Folie der Präsentation gezeigt. Da ist Ja, die beiden Teile sind ungefähr 50 Millimeter voneinander entfernt. Dafür muss man aber zum Amboss gehen. Das längere Ende kann man natürlich im Schraubstock umbiegen, aber das kürzere Ende wird wahrscheinlich nicht in den Schraubstock passen. Das muss man dann am Amboss machen. We with the Jungschmiede team decided that there will be a Christmas break in the next month. We are all busy with all kinds of different projects, so there will be no Treff in December. And the next time will be somewhere in January, and quite likely it will have something to do with cost calculation, but this is by now open to how life then happens. Wir haben mit dem Jungschmiede-Team entschieden, dass wir für Dezember eine Weihnachtspause einlegen und deswegen ist der nächste Treff erst wieder Anfang nächsten Jahres, irgendwann im Januar. Wahrscheinlich geht es dabei um Kostenkalkulationen. Das ist aber noch ein bisschen davon abhängig, wie sich alles bis dahin entwickelt. Becky, also a big thank you from my side. This has been a wonderful presentation. Yes, people are clapping in there and yes, it has been really wonderful. Thank you. Genau. Ja, Becky, vielen Dank für diese Präsentation. Einige klatschen auch schon in ihrem Bildschirm oder halten einen Daumen hoch. So seems, es sieht so aus, als wären die Leute alle sehr, sehr zufrieden. Vielen Dank.